Gravity is a fundamental force in nature that governs the behavior of objects with mass or energy. It is responsible for the attraction between objects and is instrumental in shaping the structure of the universe at both the cosmic and microscopic scales. Here is some full information about gravity. Definition: gravity is the force of attraction that exists between any two objects with mass. It is a fundamental force and is described by the theory of general relativity proposed by Albert Einstein. Universal nature. Gravity is a universal force that affects all objects with mass or energy, regardless of their size or composition. It acts between any two objects, pulling them toward each other. Gravitational field. Gravity is characterized by a gravitational field that permeates all of space. The presence of mass or energy in a region of space creates a curvature in the fabric of space-time, and other objects in that vicinity experience a force due to this curvature. Law of universal gravitation. The law of universal gravitation, formulated by Sir Isaac Newton, quantitatively describes the gravitational force between two objects. It states that the force of gravity is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Mathematically, the force of gravity, F, between two objects is given by the equation F equals g, m1 * m2, r squared. Where F is the force of gravity, g is the gravitational constant, approximately 6.67430 times 10 to the minus 11 n, meter per kilogram, squared. m1 and m2 are the masses of the two objects, and r is the distance between their centers. Gravitational constant. The gravitational constant, g, is a fundamental constant of nature that determines the strength of the gravitational force. It is an empirical value that has been measured experimentally. Gravitational acceleration. The acceleration due to gravity is the rate at which an object accelerates when subjected to the force of gravity. On the surface of the Earth, this acceleration is approximately 9.8 meters per second squared, meter per square second, and is denoted by the symbol g. Orbits and planetary motion. Gravity plays a crucial role in the motion of planets, moons, and other celestial bodies. It keeps them in orbit around larger objects like stars and governs the dynamics of their motion in space. According to Kepler's laws of planetary motion, planets move in elliptical orbits around the Sun, with the Sun located at one of the foci of the ellipse. The gravitational force between the Sun and the planet provides the centripetal force necessary to keep the planet in its orbit. Time dilation and gravitational waves. General relativity predicts several phenomena related to gravity. One of them is time dilation, where time appears to move slower in the presence of a strong gravitational field. This effect has been confirmed by various experiments and observations. Another prediction of general relativity is the existence of gravitational waves, which are ripples in spacetime caused by the acceleration of massive objects. In 2015, gravitational waves were directly detected for the first time, providing further evidence for the theory of general relativity. Open questions. Despite our understanding of gravity, there are still open questions in physics. The unification of gravity with other fundamental forces, such as electromagnetism and the strong and weak nuclear forces, into a single theory, quantum gravity, remains a challenge for researchers. Additionally, the nature of dark matter and dark energy, which have significant gravitational effects, is still not fully understood. Gravity is an essential force in the universe, shaping the motion of celestial bodies and influencing the structure of galaxies.